All right, the property we're going to look at today is called the distributive property. Um, and the best way to explain this is using friendship bracelets. I know it sounds a little weird, but it kind of helps you understand what's going on. So up here at the top, it says you decide that you're going to make friendship bracelets for some of your friends. To make the bracelet, you need 10, let's go with red beads, and 6 blue beads. So each bracelet I'm going to make, I need 10 red and 6 blue. So if I want to write this as an expression, I know each bracelet needs 10 R. I'm just going to write R for red, and if you notice that is a variable, so 10 R. And I'm also going to need 6 blue. So again, I'm just going to put a B for blue and make that a variable. So my expression would be 10R plus 6B. Now, right underneath that, it says, write a new expression to determine how many beads you will need of each color if you are going to make 3 bracelets. Well, if I'm going to make 3 bracelets, I'm going to do the exact same thing, but I'm just going to do it 3 times. So the easiest way to write that out would just be 3 times 10R plus 6B. So that would be my expression if I needed 3 bracelets. I'm doing 3 times the number of beads I need to make just 1 bracelet. And then my last question down here says, how many of each color will you need? Well, if I'm making 3 bracelets and each bracelet needs 10 red, I know 3 times 10 is 30. So I'm going to need 30 red. But I can't just ignore the blue over here. I need to multiply the 3 times the 6 and get 18 blue. So when it's all said and done, I'm going to need 30 red and 18 blue. This right here is the distributive property. I distributed the 3 into everything on the inside, to the 10R and the 6B. So I multiplied in to everything. Then it says right underneath this, the distributive property works the same way, and we're going to write it all 3 ways. And the first way is already given. They just have a number with on the outside of a parentheses. The second way we're going to write it is, so if, for example, number 1, I have 2 times 4x plus 7b. Well, just like before, if I distribute this 2 in to everything on the inside, I'm going to multiply. So I have 2 times 4x. I'm going to keep this sign the same, plus 2 times 7b. That's the second way I can write it. It's almost like it's expanded form. And then the last way I can write it is actually by multiplying these. So I know 2 times 4x gives me 8x, because 2 times 4 is 8. And I know 2 times 7 is 14, and I'm going to keep the b. So this is all 3 ways right here. 2 times 4x plus 7b is equivalent to 8x plus 14b. All right, number 2 is the same thing, but you may notice I have this 4 written on the other side over here. Same idea, though. I'm still going to distribute the 4 into everything on the inside, and I'm going to write it out the expanded form first. So first I'm just going to do 4 times 7. I'm going to keep the same sign. So since I have a minus, a negative, or subtraction, I'm going to write subtraction. And then I have 4 times x, which is just 4x. And then I can actually solve this. 4 times 7 we know is 28. Keep the subtraction, and then 4 times x is just 4x. So all 3 of those are equivalent. All right, my last one is the same thing, but this time I have 3 terms inside of my parentheses. I'm still going to distribute this 5 into everything on the inside. So I have 5 times 2x Keep this sign the same, so minus 5 times 4a plus, keep that sign the same, 5 times, it's cutting off, 5 times 7. I know that kind of cut off, but we'll do it underneath it. So 5 times 2x is 10x minus 5 times 4 is 20. Keep the a plus, and then remember we had 5 times 7, which is 35. So all three of those ways are the same. That is the distributive property right there. Now, there's one more thing we can do with the distributive property, and you're going to use this a lot the older you get. It's called factoring, which is basically the distributive property backwards. So instead of multiplying into the parentheses, we're taking a number out. So our example right here, we're going to go back to the friendship bracelets. It says, suppose in total you use 14, let's stick with our same colors, red beads and 21 blue beads. What is the most bracelets you could have made so they're the same number of each color bead? So I have to figure out what number can go into 14 and 21. Well, if I think about it, the biggest number that can go into both is 7. So if I made 7 bracelets, I know 14 divided by 7 is 2. So I'd have 2 red bracelets. And if I had 21 blue beads to start with, I know 21 divided by 7 is 3. So I could make 7 bracelets. Each bracelet would have 2 red and 3 blue. And basically all I did there was go from this 14 red and plus 21 blue, and I took a 7 out, and I ended up with that. So we're going to practice 3 of them down here really quick. I have 12x minus 18y. Well, if I think about it, the biggest number that I could take out, I could take out 2, but I want to take out a 6 because that's the biggest number I could take out. 12 divided by 6 is 2. Because remember, now I'm going outside of the parentheses. So instead of multiplying, I'm doing the inverse. I'm going to divide. I'm going to keep my sign the same. And then 18 divided by 6, I'm still going out of the parentheses. So I'm dividing is 3, and I'm going to keep the y. So those are the same. Those two expressions are equivalent. Now on 2. 45r plus 15. Well, I know 15 is the biggest number that can go into both of those. 45 divided by 15 is 3. And I'm going to keep my r. Plus 15 divided by 15 is just 1. So I have 15 times 3r plus 1. And then my last one, I have 8 and 16. Well, 8 is my biggest number. And I know 8 divided by 8 just leaves me with 1x. So I'm just going to put an x, keep my subtraction sign, and then 16 divided by 8 is 2. So I have 2y. So that is the distributive property right there. We can multiply into everything inside the parentheses, or like we saw down here, we can factor a number out and make a new parentheses with it.